Alright, hello everyone. So in this video, I'm going to solve several problems from case 2 in partial fraction decomposition. So if you look at the first example here, clearly the numerator has the polynomial with the highest degree, right? The numerator polynomial is third degree and the denominator polynomial is of second degree. Okay, so what is the first step? Use polynomial lone division. So let's divide x cube plus 2x square minus x minus 1 by x square plus 5x plus c. So here's something. In case 2, you don't have to factor the denominator in the beginning of the problem. See, I didn't factor the denominator. You have to do that in case 1 but not in case 2. Okay, otherwise it's going to be extremely inconvenient to do the polynomial lone division if you factor it. Okay, so postpone the factor in denominator. So let's use polynomial lone division. So x cube versus x square. So to create x cube out of x square, you have to multiply x square by x. Now re-multiply everything here by x. So it's going to be x cube plus 5x square plus 6x. Now you subtract, do the subtraction carefully. Okay, x cube cancel out. 2x square minus 5x square is negative 3x square. Negative x minus 6x is negative 7x. Minus 1 comes down for free because there's nothing to subtract from minus 1. Alright, now again look at the first term, 3x square and x square. So to create negative 3x square out of x square, you have to multiply by minus 3. Now re-multiply. Negative 3x square here, negative 3 times 5x is what? Negative 15x? Yeah. Negative 3 times 6 is negative 18. Subtract. So 3x square cancel out. Negative 7x minus 15x. Be careful. This will become plus. So it's 8x. Negative 1 minus 18 is what? Minus 19. Right? This should be, yes, this should be minus 18. Right? See, I made a mistake. So this should be plus 18. So it should be plus 17. Okay. Glad that I code that up in the video. Okay, otherwise I have to make the video again. All right, so now let's continue. So how about x square and compare 8x? Well, now here we have a first degree polynomial, here we have a second degree polynomial. So we reach up to a point where the remainder is actually a polynomial less than the divisor. So we stop here. Okay, so what is q? Q is quotient is x minus 3. What is the remainder? Remainder is 8x plus 17 and the divisor is x square plus 5x plus 6. Alright, so what is the decomposition then? Q plus x minus 3 plus remainder is 8x plus 17 divide by the divisor x square plus 5x plus 6. Okay, so this is the first step. Use the polynomial lone division to break up the rational function. Now here, as we expected, here we have a rational function which belongs to case 1. Now do the decomposition for that part separately. Now before we move on to that, I want to share something. So look at this x minus 3. It's a first degree polynomial. Now you can anticipate a first degree polynomial if you carefully look at this rational function. I mean, you are dividing a cubic polynomial by a quadratic function. So third degree polynomial by a second degree polynomial. So when you divide a third degree polynomial by a second degree polynomial, the difference is 1, right, between the degrees. So you should get a linear function, right, a first degree polynomial. So you can anticipate a first degree polynomial here. Something that I thought that I should share. Okay. Anyway, so now you have to keep this x minus 3 every time you write this expression. Okay, don't forget about it. Now do the decomposition for this fraction. To do the decomposition, you have to factor the denominator because this is case 1 now. So if you factor x square plus 5x plus 6, it's going to be x plus 2, x plus 3. Okay, now based on the case 1 scenario, we have distinct linear factors. So the decomposition is a over x plus 7, a over x plus 2 because this is x plus 2 plus b over x plus 3. I use case 1 strategies. Okay, and notice that I keep writing x minus 3, the quotient. Okay, well, that's the decomposition. Now it's just we need to find the constants. So to find the constants, you don't have to deal with this x minus 3. Here's something you can do. You can think this as a separate problem. I mean, what you did is you decompose 8x plus 17 times divided by x square plus 5x plus 6. You decompose that into a over x plus 2 plus b over x plus 3, right? That's what you did, right? Right here we did a small decomposition for that part, so you can just use that part. You don't need to deal with x minus 3 on the left hand side. Just use this small part to figure out a and b. So let's do that. So if you multiply everything by this big denominator, on the left hand side you get 8x plus 17, here a times x plus 3 plus b times x plus 2, right? We already saw this. Well, x square plus 5x plus 6 is actually x plus 2 times x plus 3, right? We already know that. So when you multiply by that, this is what's gonna left. So the magic numbers are x is equal to negative 2. If you use negative 2 here, negative 16 plus 17, right? If you substitute negative 2, negative 2 plus 1 is, negative 2 plus 3 is 1. So this is a. 8 times 2 is 16 plus 17 is, yeah, negative. So a is 1, right? So we get a to be 1. Am I doing this right? Yes. Now if you use x is equal to negative 3, the other magic number here, we can find b. So negative 24, if you substitute negative 3 plus 17, okay, is equal to negative 3 plus 1, negative 3 plus 2 is negative 1, so negative b. So here it seems to be like what? B is going to be 7, right? Yes, B is going to be 7. Okay. All right. So then what we are going to get, our decomposition is x minus 3 plus a is 1 over x plus 2. B is, let's see, 7. So it's 7 over x plus 3. So yeah. This is the decomposition. Okay, full decomposition. All right. Now let's do another problem. Let's actually do couple more. Let me show you something. So the new problem is x square plus 2x plus 1 divided by x square plus 10x plus 21. Okay, so now the degrees are equal. So what do you think? Well, still this is case 2, okay? So if even the numerator and denominator degrees are equal, still it belongs to case 2. So you have to do polynomial lone division. So if you use the polynomial lone division, what do you anticipate? What kind of polynomial you would get as your quotient? Well, this is second degree. This is second degree. 2 minus 2 is 0. So you should anticipate a constant as your quotient. Okay, so we'll see. So x square, you just multiply by 1, right? So remultiply x square plus 10x plus 21. If you subtract, x square cancel out. 2x minus 10x is minus 8x. 1 minus 21 is minus 20. Alright. Now here, the first term is negative 8x. The first term is x square. Now you can see this is a smaller degree polynomial than the divisor. So we stop here. So what is the quotient? Quotient is 1 as we expected. It's a constant. And remainder is negative 8x minus 20. And the divisor is x square plus 10x plus 21. Perfect. So let's write the initial decomposition. It's quotient plus the remainder over the divisor x square plus 10x plus 21. Alright, so now here we have a case 1 scenario where the numerator has the polynomial with lowest degree. So we decompose that. So 1 plus factor the denominator. So denominator is going to be x plus 7, x plus 3 if you factor. I did that fast. So we have distinct linear factors. So 1 plus a over x plus 7 plus b over x plus 3. So that's the decomposition. Now to find constants, you don't have to use the full term. Just use the term that you used to decomposition, the case 1 term. So x plus 7, x plus 3. The decomposition we got is a over x plus 7 plus b over x plus 3. Now to find constants, multiply everything both left hand side and right hand side by that big denominator. So on the left hand side, minus 8x minus 20 is equal to a. If you will left with x plus 3 here, you will left with x plus 7 here, right, when you multiply it. Okay, perfect. Now the magic numbers are, to find a, we can use x is equal to -7, right? So if you substitute -7, let's see what we get. -7 times 8 is plus 56, right? 56 minus 20 is -7 plus 3 is -4a. So 56 minus 20 is 36. 36 equal to -4a. A is -9. Perfect. Alright, to find b, we can use the magic number -3. So -3 times -8 is 24. 24 minus 20 is -3 plus 7 is 4. B then. So b is seems to be like 1, right? Okay, perfect. We got the constants. Then the full decomposition is 1 plus -9. So we can get rid of that plus. -9 over x plus 7. B is 1 over x plus 3. Here we go. This is the full decomposition for the second problem. Alright. Okay, so let me do just another one problem. Alright, so the final problem is x to the 4 plus 3x plus 1 divided by x square plus 2x plus 1. Okay, this is a little bit special. Now here again the numerator has the polynomial with the largest degree, so use polynomial lone division. This is x to the 4 plus 3x plus 1 divided by x square plus 2x plus 1. Now what kind of a polynomial you would anticipate for the quotient? Here this is 4th degree, here this is 2nd degree, 4 minus 2 is 2, so 2nd degree polynomial for quotient. So let's see. To create x to the 4 out of x square, you have to multiply by x square. So let's do the polynomial lone division fast. Let me do that fast because I want to keep this video short. So this is 2x cube plus x square. Alright, so here I didn't do something. So actually I should have 0x cube here plus 0x square. That's a good practice to have them here, right? Even though they are not there in the polynomial, so that it makes our life easy. So subtract. x4 cancel out. 0x cube minus 2x cube is minus 2x cube. 0x square minus x square is minus x square. These things comes for free. 3x plus 1. Alright, so to create -2x cube out of x square, we have to multiply by -2x. Multiply by -2x back, so -2x cube, -4x square, -2x. Now use the subtraction. So if you use the subtraction, this will cancel out. -x square minus 4x square is 3x square. 3x minus -2x is 5x, okay? That becomes addition in the middle, and here 1 comes for free. Okay, so this is rather a lone polynomial, lone division. Okay, so here to create 3x square out of x square, we have to multiply by what? 3. So plus 3. So remultiply. So 3x square plus here if you multiply 3 by 2x, it's 6x. 6x plus 3 times 1 is 3. So here we get 3. Alright, now subtract. So 3x square cancel out. 5x minus 6x is minus x, and 1 minus 3 is minus 2. Alright, so now we have a linear polynomial, a first degree polynomial, and device is a second degree polynomial. So second degree polynomial is larger, so device is larger than the remainder, so we stop here, right? Okay, so what is our Q? Alright, so we get our quotient to be, as we anticipated, a second degree polynomial, x square minus 2x plus 3. Remainder we got minus x minus 2. And our divisor was x square plus 2x plus 1. Alright, so let's write the full decomposition. So Q, x square minus 2x plus 3 plus remainder is minus x minus 2. Divide by device is x square plus 2x plus 1. Alright, so now you have to worry about this part. So this is a case 1 fraction. Don't worry about this. Let him be like that. Okay. So keep writing that term, x square minus 2x plus 3. So here we can factor this one. We get, if you factor x square plus 2x plus 1, you get x square, x plus 1 square. Now this is a repeated factor, right? Repeated twice. So using the case 1 strategies, the decomposition is going to be a over x plus 1 plus b over x plus 1 square. See, inside case 2 you do a case 1 again, right? Because we have to do case 1 strategies for this fraction. Alright, so to now find the constants, we can just use the small part of the fraction minus x minus 2 x plus 1 square. So what we got is a over x plus 1 plus b over x plus 1 square. Alright, so now if we multiply by this common denominator, we get minus x minus 2. Here a is, if you multiply by x plus 1 square, you will left with a 1x plus 1 and plus b. Alright, so now here what we can do is well distribute a times x plus 1. So this is ax plus a plus b. So if you group them, so this is ax plus a plus b. Alright, so let's compare the coefficients. So if you compare the coefficient of x should be same. So on the left it's negative 1, on the right it's a, so a is negative 1. Perfect. And negative 2 is a plus b. If you compare the constants on the left and right, a is negative 1. So what is b? B is also negative 1, right? Yes. So we got a and b. Perfect. Now our decomposition is going to be, let's complete it. So x square, so let's write it, x square minus 2x plus 3 plus a is, what was a? Negative 1. So we can get rid of this negative 1 over x plus 1, and b is negative 1 over x plus 1 square. So this is the full decomposition. Okay, all right, so that's how you solve problems with in case 2. Okay, so in a nutshell, when you have case 2, do the polynomial lone division, find q and r, quotient and remainder, then write the initial decomposition, and then the remainder over divisor will be a case 1 fraction. Apply case 1 strategies for that part, and then complete the decomposition. Okay, don't forget q. All right, so I'll see you in the next video. Thank you very much.